In this part of the presentation, I'll demonstrate what happens when you process analysis services database. The processing reads the data from actual relational database and stores it in subfolders, which we talked about previously. As we talked before, if you have just a database subfolders for dimensions and for cubes, when you do the processing, all these folders will be populated. So dim product folder is empty right now. If we go ahead and actually I'll do just a simple processing right now, just to demonstrate, so one single dimension, dim product. The processing of that, it's process full right now. Processing will actually go ahead and start to create the files. A lot of files in that folder for each object you process. That's where actually you're storing all the data. The data is copied again from relational database to this multidimensional database. The format here, the way the data is stored, it's not easy to understand. It is very well described in the book by actually I can demonstrate this book. It's Microsoft SQL Server Analysis Services Unleashed. It's that book. This is a version for 2005. There is also a version for 2008. This book was written by Edward Melamed, Irina Gorbach, Alexander Berger, and Pi Bateman. These are the people from Microsoft team who wrote how analysis services works. These are SSAS team members. So when we process analysis services database, as I said, per each attribute, specifically for this dimension, each attribute has multiple files created for it. If we look at the, right now everything is ordered by name. If you look at the class attribute, wherever the names of class, you see multiple files created. There are string stores, there are attribute stores, there are hierarchy and relationship. I mean, there are a lot of files created for each attribute. And honestly, you don't have to know how analysis services stores the data inside these files. You just have to get a very high level understanding that if you want to figure out how much that each attribute space takes, you just come here and you go into the search toolbar, and if you want to find whatever is in class, these are all the files with the class attribute name. So 14 files as you see in here, and you can see here roughly the size for each attribute. So if you add this information together, you would get an idea impact of that attribute to your dimension. So let's delete that. So as you see, as we talked about, that processing actually moves data. I want to reiterate that because we're talking about multidimensional storage. Processing takes all the data from your relational database and puts here into this file structure. If you look at the files that are created, majority of them are very small, because these are kind of index files or some other storage files stored in a proprietary analysis services format. They use data IDs instead of actual strings and so on. So they really small files. It's efficiently to read them. And as analysis services creates a lot of small files, there was one recommendation I want to point that it came from analysis services team, was that you should be storing your analysis services data on the disk with disk unit allocation size of 32 kilobytes. Normally for data warehouse database, Microsoft recommends to store relational data files, MDB files, LDF files. Sorry, not MDB, MDF and LDF files to be stored on the disk with the disk allocation unit size of 64 kilobytes and more. But here for analysis services, recommendation was to store on 32 kilobyte size, disk unit allocation size. That that actually changed a bit. I've seen now different recommendations, and the proper answer would be, as always, it depends. But you should be aware of the fact that there are a lot of small files that will be read from your disk where you store analysis services database. For specifically, if we're looking at this dimension, single dimension generated 329 files. That's a lot. And again, you don't have to know exactly what is in each of these files. You can just roughly add them together, and actually you know the size of the dimension like that. So let's do the processing again, and I want to now do the process of the whole database. So not just a folder, not just dimension, but a whole database. And I'll do the process full whole database. And while we're doing the process full or all database, we actually, it's going to take just a bit of time. It's going to take a bit of time to finish it. And after this processing of whole database is done, we'll go through dimension subfolder. We'll pick one dimension and we'll look what can we find in the dimension folder, what information is useful for us. And then we'll go into the partition folder and we'll try to see what information is interesting for us in an actual partition folder. As this analysis services database have a data mining structure, we're not going to go or analyze that. That's not our purpose for this presentation. So we'll just ignore that part. So if we look at the number of records right now, it's at 657. It was 300. As I said before, analysis services creates a different version file. You see ones and twos right now in this dimension folder. These are the different versions for the each attribute to process. When the processing will be complete, all the old ones will be dropped, and the two ones, the new version of the file will stay there. So let's finish till it finishes done before we go ahead. And we'll go ahead and let's look at our product dimension, because we'll analyze that dimension. We'll see how the information is stored for this dimension in related folder, and then we'll pick one of the measure groups. I think we'll pick AdventureWorks, some of the internet sales, maybe the folder, and we'll see how information is stored for that there. So processing still is done. I have okay, is it done? It's done, and we go back to the folder for this dimension, and we see that now version is all the twos, all the ones are gone. So the first step in this part of the presentation will look what can we get out of the dimension folder. If I'll go back just very quickly in my Power Pivot, there are a lot of SSAS data files in this folder. So we have these are the names like .ass store, it's property string store. We have a property hash store, property store. Again, much more is analysis services unleashed book you can buy. And we don't really have to know about the actual how information is stored. So all these extensions. So what do I do when I go about when I analyze dimensions? The first thing which I like to do is to get the size of the dimension. It's very easy to get the size of the dimension from when you look at the folders. It's just you go there and you get an idea, what dimension size is, and you can easily write a PowerShell script or other script that just iterates through all these subfolders and gives back to you some information about folder sizes. So that means your dimension sizes or cube and partition sizes. So with the 2 clicks we got the size of the dimension. It's not easy to get that information from the Business Intelligence Development Studio or Management Studio. I don't even know, to be honest, when I say it's not easy. You'd have to write probably some sort of AMO script to iterate through the objects to find out that size. Yet, if you come here and you just right mouse click on the folder and you get it, you get that information very quickly. So size of the folder, this is one of the, or sorry, size of the dimension, it's one of the things which I look when I go and analyze dimension, and it's really easily available. The second thing which I can, very quickly I can see is when the last time this dimension was processed. You just look at the data modified timestamp, or you go inside and look at data modified timestamp for its attributes, and you know exactly when this dimension was processed. Very convenient, because sometimes clients will tell you that they did process incrementally dimension, but the data is not there they expect, and you can go here and you can see the timestamp when really it happened. So this is the second thing which I usually look into in this folder. The third thing is I really like, and that's just for the bigger dimensions, I want to go inside of dimension folder and I want to see what attributes really take most of the space in that dimension. So for the big dimensions, I come in and I order that folder by size, and I can very quickly get an idea, you know, that's for the sizes of attributes in each in this dimension. So I like to order it by size, because usually you have a few attributes that take the actual most of the space and dimension, and in this cases they just at the top, and you can see just some of the files of these attributes. You don't see the whole all the files for that attributes, but if you see that large photo, that's a attribute that takes a lot of space. If you order it now by the name, these are the large photo. This is you can see that, yes, if you add together all these attribute sizes, you'll know that it takes almost 6 kilobytes in this case, that this attribute uses about 6 kilobytes of storage. There is no other easy way for you to get information how much space the attribute uses in that dimension, except if you come to this folder. Okay, it's really easy, and you don't do this for the small dimension. For small dimension, it doesn't really matter. You don't analyze that. It would be just, you take too much time. But for large dimensions, and usually you do know that dimensions which has millions of records, you better come into this folder for that dimension, and you better see impact. Sometimes you might be surprised of, you know, that what attributes really take so much space. And it's a good idea if to review these attributes and double check, do you really need them? That's especially true for 2005, where the dimension wizard actually was trying to add all the fields from that table as attributes for your analysis services dimension. So if you come into this folder, you see all these large attributes, make sure you really need them. So from the dimension, these are the biggest things that I usually look at. The one more thing for very large dimensions that you should look at is the files which are close to 4 gigabytes. In 2005, 2008, 2008 are 2 releases. These there is a limit of analysis services string store. It cannot be more than 4 gigabytes. So if you see that some of your attributes are approaching 4 gigabytes, you have to figure out what to do. This issue was resolved in 2012, SQL Server Denali, with introducing the different store. But in 2005, 2008, you have to, if you're one of the strings or if one of your attributes is approaching 4 gigabytes, you have to do something about that. You have to probably change a design or try to reduce that string size, or other ways to solve this issue. So this was, we just looked at one single dimension, and all dimensions, other dimensions have a it's kind of the same thing. You come in for the big dimensions, you look at the size, big size attributes, and then you can actually see how much each attribute takes space and when it was processed. So as we looked right now at the dimension, the next important information we can get out of the partition folder. So if we go into specific partition, and we'll go against internet sales partition, before, when I showed you when partition was just deployed, inside of this partition it was empty, there was no data. Now when we process that partition, we suddenly have some data in there. And let me see, I think which partition has a bigger data. This was very small. So if you go into partition and you see no indexes created, that's probably because you have very little data in that partition, and analysis services chose not even to create an indexes. Okay, so this is a sample case of that, where there is no indexes, it's just a fact data. So .fact data, it's where you store the fact data. So that's another partition where there's no data. And then if we'll go into the other partitions which had more data specifically, then you see indexes and data. So let's look what type of data files are created. I have it somewhere in my slides here. So this slide is these type of the file extensions are more relevant to the partitions of folder. So data stored here has the data file extensions are .fact.data, for example, and .fact.data.hdr. That's a header file. So the header file, it's basically they come in pair. It's kind of additional metadata or information about your data. So we have a map store data file. It's actually .fact.data extension where your actual fact data is stored. We have a .fact.map files in partitions of folders. We have a lot of them because there is one file for each dimension attribute here with this extension. These are the bitmap indexes. So for not per dimension, but per attribute, per dimension attribute, we have a bitmap index files for specific partition and related header file. And then we also have aggregation files. We have a aggregation flexible, so .agg.flex data file, and we have a .agg.rigid file. So we have aggregation data stored in separate places for the attributes which have a flexible relationship versus attributes that have a rigid relationship. You've heard this before in some other presentations when somebody would tell you, set attribute relationship type to rigid if it doesn't change it. So it's actually, I will demonstrate later in another part of this presentation why it is important to do that. As you can see, the flexible aggregation and rigid aggregation data are saved in a separate files. And this is done because if you change your dimension data, that is part of flexible relationship, it's used in flexible attribute relationship, analysis services will drop the index file for that attribute which you changed, and will also drop all the flexible aggregations, not just for that attribute, but all the flexible aggregations for that measure group partition, wherever you were processing, or actually wherever is affected. It's not just for single partition, it's actually wherever is affected, where this attribute was used in aggregation. So this is very important, and actually I will demonstrate that later. But what you should be aware right now is that you store the data in a fact files, that's clear. Then you store a data in flexible aggregations, and you store a data in rigid aggregations. And the another important part, we have a lot of index files. There will be a lot of index files for each attribute. So let's go back into our partition for an internet sales, and that's exactly what we see here. It was easier to see when we ordered by size. We have let's see, where is the fact data? So let me filter this for data. So we have a fact data here, and the fact data size is 692 kilobytes. And there is a header which is small, not important. Then we have a rigid aggregation data, which is 256 kilobytes in size. And we have a flexible aggregation data, which is 227 kilobytes in size. So this gives you an idea about how much your data takes space. And all these other files, you see a lot of the other files. And let's pick one attribute, and I'll pick one attribute in a product dimension, so we can just analyze. In the product dimension, we have a model name attribute. So we'll just filter it by model name. Okay, so this model name, as you see, have a few files. The single attribute has a fact.fact.map. That's a bitmap index file for the fact data. It's also have a file. Let me just for the aggregate flexible and aggregate rigid index file. So I can't order it here. As you can see, there are, even per one attribute, per one dimension attribute, you have multiple files. This data is stored in multiple files. And it's actually important concept that, and I want to repeat it again, that you have a index for the fact data, you have an index for the aggregation rigid, and you have an index for aggregation flexible. So these are three indexes, and these are three matching the header files per each attribute. And we see all this per each attribute. So if we look at our partition, we have 449 files. So this specifically single partition for this 2003 for internet sales, we have 449 files created. So what do I look for the partition? What's usually what type of analysis I do? The easiest thing which I do is, if I'll go back onto the cube size and I want to know what is the size of the cube, you just right mouse click on .cub folder and you see the size of the cube. The same way, you can go into the cube file and you can select any measure group, and you can very quickly get the size of that measure group. Specific measure group, this measure group takes so much size. Very easy and very quickly to find this information from this database folder. The same way, you can always see what time the measure group was processed, even in what time the specific partition was processed. Okay, that's very also useful information. You can very quickly get from the database folder. The next thing which I also usually try to look is that's inside of partition folder. I want to get an idea about the size of the data and the size of the aggregation. You've heard probably a rule before it was especially pushed that your aggregation should not be more than 30% of actual fact data. You add this flexible aggregation and rigid aggregation data files together, you get about close to 500 kilobytes. The fact data is 693 kilobytes. So yes, aggregation data in this case is bigger than recommended 30%. Not a big deal for this size of the cube. When you have large cubes and you start to see that your aggregation sizes are very big, you have to think if it's really worth for you to create so many aggregations, because if the size grows, it becomes not really efficient. This is very easy to get that size from the fact data and aggregation data by looking at the folder. There is no other way where you can get the same data split like that easy. There is just no other way where you can query and get this data. Just by looking at the folder, that's the simplest way I can imagine where anybody can go and quickly get the good idea about the sizes of their fact data and aggregation data. And now the next thing which I want to look at is in this partition folder. It's how big. I want to look. I usually order by size, and I want to see how much the biggest attributes take space in this partition. What usually I want to find is the few top attributes. Usually it's just there are very few top attributes that takes more than more the space than I usually would expect. Or as you see, majority of attributes will not take that much space. But some of the attributes, unfortunately, the bigger dimension attributes might take a lot more than you expect space in your partition. Let me show you a quick, I think I have a somewhere screenshot. This is the screenshot for dimension folder, and I have somewhere the screenshot. So for large partition, for example, so my fact table is about 4 GB in size, and fact table data is 4 GB in size. There is no aggregations for this fact specifically here, and I have a few attributes here that actually takes much more than other attributes in size. And this specifically, this was the case. I did a screenshot where I had a surrogate dimension, which really these attributes are not really used. I don't need to index them, but they were indexed. I don't need to index them because if it's surrogate dimension, the surrogate key level is never accessed by end user. It's never queried by that. So you can do is actually you can go ahead and disable that attribute. So by disable that attribute is you go on the attribute, you select it, you select that attribute, and you change the property of that attribute from fully optimized to not optimized, and the indexes in that case would not be created. So you would not create this bitmap indexes here in this folder. So it would be, you would save the storage space, and you would save a space of the so you would save a time for creating that indexes. So you have to review the biggest indexes for partition and see, do you really need them? Now, I give you here example for one partition. Usually you see the same pattern through other partitions. So you don't have to go through a partition where this dimension is used and analyze how much space it takes here. Usually the same pattern goes through all partitions, and even in many cases the same dimension placed the same way in the other cubes as well. So, but when you analyze one partition, you get very good idea how much space that attribute takes in that partition, and if you see that it takes a lot of space, you have to pay a bit more attention and figure out, do you really need that attribute? Do you really need the index for this attribute? And this way you can impact your size of the cube and performance speed for that. So these are the main things that I look when I analyze the partition information. Just to sum up, so we looked through the dimension folder, and we figured out that from dimension folder we can actually very quickly get an idea when dimension was processed, what is the size of the dimensions, what are the size of attributes, and also we looked at the partition folder, and we saw what same way we can very quickly get information on what the size is of that partition, of that cube, of the data, of the fact data, of the aggregations, and what is even the size of the attributes for the specific for the specific partition. So when you design, I just want to point it out, when you design the dimension, and in many cases you have to, client comes in and says, okay, I want to add this attribute to this dimension. For small dimensions, it's not a problem. You just go ahead and you add it. You know that impact probably will not be a big, and you can handle it. For the bigger dimensions, you have to keep in mind that there is an impact for the dimension size. So your dimension will grow a bit, and then there is an impact for every single partition where that dimension is used, because you're going to have to create additional indexes for that attribute. You'll have to, it's going to take a space, it's going to take a time to create all these things. So these are the things you have to keep in mind, and having access to these folders here, to these analysis services folders, it can help you decide, it can help you figure out what is that impact when you create, when you add additional attributes to dimensions. So this was what I wanted to show you mostly. This was important part, what I wanted to show you, what you can learn when you go into the dimension folder, what you can learn when you go into the partition folder, and how it can help you actually when you do the design of your analysis services database. In the next part, I'll show you a demo of what happens when you actually do the process update on the dimension. So stick with me and watch second part.